Okay, so this video is a follow-up to the previous video. If you haven't watched the first video on arc length, make sure to go watch that. But in this video, I'd like to work some additional example problems. I think that some folks would benefit from that. The central idea with all of these problems is that the measure of an angle inside of a circle is equal to half the measure of its arc. So whatever the inscribed angle inside the circle is, the measure of its arc will be twice the measure of the angle, or you could say the measure of the angle is half the measure of the arc. So there's that relationship there. So let's dive into these additional example problems and see if we can make heads or tails of that. So again, make sure you watch that first video before jumping into this video, because I go over some other prefatory material. Looking at this problem, we're trying to find the measure of arc XC. So let's just figure out what that is. That's this little arc right here. We're trying to find the measure of that arc. Now, we're not given enough information to find that just right off the bat. We have to solve some intermediate problems before we can get to that piece that we want at the end. So let's notice something. We are given the measure of angle E is 3x plus 7. Okay? So let's look at that. The measure of angle E is this whole angle right here. From here to here. So what we can say is that whatever angle E's measure is, twice that angle will be the measure of this arc all the way from D all the way to X. And we are given those measures in algebraic form. Okay, so what we have to say is the measure of angle E is equal to half whatever this whole measure of this arc is. So setting that up algebraically looks like this. The measure of angle E is equal to 1/2 open parentheses, and now we have to add arc DC and CX. So we'll say measure of arc DC plus measure of arc CX. Okay, so there's your setup. And what we have to do is just substitute in our algebraic expressions. So where we have measure of angle E, we'll write -3 plus 7x, and DC we'll write 8x plus 10, and then CX 5x minus 5. So let's try to get that all in frame here. So our next step is to substitute in for these measures. -3 plus 7x goes right here. -3 plus 7x equals 1/2 open parentheses, and then measure of angle DC is 8x plus 10. 8x plus 10. Measure of angle CX is 5x minus 5. So plus 5x minus 5. Close parentheses. Okay, now we can zoom in and work on this algebra problem. The first step is to combine like terms. So we can combine this 8x with this 5x, and we can combine the 10 with the -5 inside the parentheses. So again, this first stuff here, we're just going to rewrite this again because we're not doing anything to the left side yet. -3 plus 7x equals 1/2. So nothing changed, open parentheses. And now we do the yellow, 8x plus 5x, that's 13x. And then 10 minus 5, 10 plus -5 is just 5. So plus 5, close parentheses. And now we have to do some distribution. We're going to distribute that 1/2 through the terms of the parenthetical algebraic expression. So we're going to rewrite the left again. -3 plus 7x equals 13 over 2x plus 5 over 2. Okay, leave those like that. We're going to combine these terms. First, we're going to move this 13 over 2x to the left side by subtracting 13 over 2 from both sides, 13 over 2x from both sides. Okay, on the left, or on the right rather, that cancels out. Okay, so we have to do a little bit of side work before we can finish this subtraction. We have to get 7x to be something that has a 2 in the denominator, because this 2 requires that we have 7 with a denominator of 2. So we have to multiply 7x times 2 over 2. Okay, and that equals 14 over 2x. So we'll substitute that back in. We have negative 3 plus 7x plus 14 over 2x equals 5 over 2. And now we can combine these like terms right here. Oops, I'm writing this incorrectly. We go back. Well, we have negative 3 plus, and then here's this, we're going to substitute in for 7x, this 14 over 2x. And then we do minus 13 over 2x. You'll see why we left it in this fraction form, equals 5 over 2. Okay, so now we can work on this. We have 14 over 2 minus 13 over 2x. So it's just 14 minus 13 is 1. So we have 1 over 2x. So we'll write the next step is negative 3 plus 1 over 2x equals 5 over 2. Well, now we need to add 3 to both sides. And we have 1 over 2x equals 5 over 2 plus, and now we need 3 in terms of 2. So we have to multiply 3 times 2 over 2. So that's 3 over 1 times 2 over 2 equals 6 over 2. So we have 5 over 2 plus 6 over 2. So let's zoom out a little bit. Now we have 1/2 x equals 5 plus 6 over 2. So 5 plus 6 is 11 over 2. Okay, now to get x by itself, we just multiply by the reciprocal 2 over 1 on both sides. And that's nice because all these cancel out and even these 2's cancel out. And so x equals 11. Okay, so that's not the answer, but that is what x equals. We're trying to find, going back to this, we are trying to find this arc measure right here. Okay, so that arc measure is 5x minus 5. Well, we now know that x equals 11. So we can say, all right, we can say this sentence here. If x equals 11 and the measure of arc CX equals 5x minus 5, then the measure of arc CX is equal to 5, open parentheses, 11 minus 5. So the measure of arc CX is equal to 55 minus 5, which is just 50. So it should be the measure of arc CX equals 50 degrees. Let's go see if that was one of our answer choices. And sure enough, it is. D, 50 degrees. Okay. So now we'll move on and do the other example from the system of equations part. So the way that you think about this is the opposites. You're always looking at the opposites. So The opposite of H is Q. The opposite of R is P. And so remember, the sum of these opposite angles have to add up to 180. Remember, the full way around the circle is 360 degrees all the way around the circle. So if you have this measure of angle H and you look at that arc, P all the way over to R, that has to be 180. That's half the circle. And so then you look at the measure of angle Q, okay, and its arc all the way from R to P, that has to be 180. So they have to add up to 360. And remember, the measure of the sum of those two angles has to be equal to half the measure of the full arc. And the full arc sum would be 360 degrees, so the angular sum would be 180. So we're actually going to be working here with these interior angles. So what we'll write is our first system we'll start to do up here. We'll do the H and the Q. We'll say measure of angle H plus measure of angle Q equals 180 degrees. Okay, so we'll say for measure of angle H, we'll write 7y plus 1 plus the measure of angle Q, 7x plus 4, equals 180 degrees. Okay, we'll just put 180 for now. And now we're going to combine like terms. We can do the 1 and the 4. So we have 7y, 1 plus 4 is 5, plus 5 plus 7x equals 180. And we can subtract the 5 from both sides. Cancels out. And so we have 7y plus 7x, this is a linear equation, equals 180 minus 5 is 175. Okay, so that's the first one. So we've taken care of these two. So now we're moving on to the next pair, which would be 6y plus 17 and 7x plus 2. Remember, those have to add up to be 180 as well. So we say here the measure of angle R plus the measure of angle P equals 180. Okay, 180 degrees. You see that when you add all of them together, H, Q, R, and P, if these equal 180 and these equal 180, together they have to equal 360, which makes sense. It's the whole way around the circle. Okay, so we'll substitute back in the values that we know. So for R, we'll put 6y plus 17, 6y plus 17. And then for the measure of angle P, we'll put 7x plus 2 plus 7x plus 2 equals 180. And we'll combine what we can. That'll be the 17 and the 2. The 17 plus 2 is 19, so we'll write 6y plus 19 plus 7x equals 180. We subtract 19 from both sides. This cancels, and we have the linear equation 6y plus 7x equals, and we'll borrow, 9 from 10 is 1, 1 from 7 is 6, and the 1. So we have 6y plus 7x equals 161. So these are our two equations. Let me highlight both of those so we can see them. We have this equation here, and we have this equation here. So those are the two equations we need to put together to form a system. And we'll do that. We'll shrink this down and do that right here. Okay. So this is the first part. Some people like to know what the first part is. This is the first part, getting these two systems. This is the first equation. This is the second equation. So this is like part 1. Okay, get your equations. Now here's part 2. we're going to solve the system of equations. So first, let's write that system out. We have these two equations, 7y plus 7x equals 175. And then beneath that, we'll write 6y plus 7x equals 161. Okay, so this is the new thing we're focusing on. And so we can actually directly eliminate because we have the 7x's match on the top and the bottom. So we can just do elimination by subtraction. Come on now. Okay, so we'll draw a line. And we're going to do elimination by subtraction. So remember, we're subtracting. We have to distribute that subtraction through the whole system. And so we'll do this piece by piece. 7y minus 6y equals 1y. 7x minus 7x, that eliminates. Okay, and now we have to do 175 minus 161. 1 from 5 is 4. 6 from 7 is 1. And so it's just 1y equals 14. So y equals 14. Well, now that we know y equals 14, we can just plug it back into one of our two equations. So this would be like part 3. So we found one of them, and now we're going to substitute. So we'll say we're going to eliminate here. Okay, and now we're going to substitute here. So we have y equals 14, so we can just go into one of our equations here and say, well, if y equals 14 and 7y plus 7x equals 175, then we can say 7 times 14 plus 7x equals 175. Okay, so we have to do 7 times 14. We'll do that in side work. 14 times 7. 4 times 7 is 28. Carry the 2. 7 times 1 is 7 plus 2 is 9. So 14 times 7 should be 98. Okay, so we'll put 98 here plus 7x equals 175. We'll subtract 98 from both sides. Cancels out. And so 7x equals whatever this is. So we'll borrow here. This becomes a 0. This becomes 16. This becomes 15. And so 8 from 15 is 7. And then 9 from 16 is also 7. And then we have 0. Okay, so it's just 7x equals 77. Now we'll divide both sides by 7. So 77 divided by 7 is 11, so x equals 11. So we have now y equals 14 and x equals 11. We do x comma y. So our answer, x comma y, the solution to this system of equations is 11 for x, comma 14 for y. Guess we don't need these brackets. We just have 11, comma 14, where the 11 is the x and the 14 is the y. Okay, so we'll put that in a red box. And let's go make sure that's one of our answer choices. X is 11, y is 14, corresponds to answer choice C. All right, so that is how you do both of those problems. And now if you've watched both of these videos, you've seen 4 different examples fully solved. And so, I hope that between all those different examples, you've managed to understand what's going on. So just going back to the beginning, the central idea of all these problems is that the inscribed angle inside a circle is equal to half the measure of that angle's arc. Okay, you could also say the arc is equal to twice the inscribed angle. So we've just been playing with that idea using algebra. Thanks so much for watching.